So where we left off was, we already know how to figure out whether a function has an inverse. The question is, how do we find it? Okay, so the way we're going to find an inverse, here's our method. So the first thing we're going to do is switch x for y in the function. The second thing we're going to do is then solve for y. So this is going to put your algebra skills to a test. And then we're going to name the y we get to be the inverse function. Now, this does not always work. There are going to be many functions we cannot find the inverse of. They're just too difficult. Some are going to be rather easy. So here's an example. So I want f of x to be 4x minus 1. Okay, this is a line, very easy, nice and simple. So y, which is f of x, is 4x minus 1. So now I'm going to switch x and y. So now I'm going to have x is 4y minus 1. So there's the switch. Now I'm going to add 1 to both sides and get x plus 1 is equal to 4y. And then I'm going to divide by 4 and get y is equal to x plus 1 divided by 4. And then lastly, I'm going to rename y f inverse. So f inverse of x becomes x plus 1 divided by 4. There's my inverse function. Okay.
Can you scroll up just a little bit?
This way?
To 2. I am right down 2. Okay. Oh, you could have told me it was. Thank you.
Mm-hmm. Okay, so what did we say before? We said that f inverse of f of x is x, and we said that f of f inverse of x is x. So let's prove it to ourselves. Oops, I didn't mean to do that. Okay. So we have f of x is 4x plus 1, and f inverse of x, no, it's 4x minus 1. I would have had a disaster. And this is x plus 1 divided by 4. Okay, so what is f of f inverse of x? Well, f says take 4 of f times f inverse of x. And then subtract 1 from it. So that's 4, f inverse of x is x plus 1 divided by 4 minus 1. So now I can see already that these two 4s are going to divide out, and leave me x plus 1 minus 1, and that gives me x. So yes, f of f inverse of x is x. And let's do f inverse of f of x. So f inverse says take f of x, add 1 to it, and then divide by 4. So f of x is 4x minus 1, add 1 to it, and then divide by 4. So I get 4x divided by 4, which gives me x. So both of them check. Okay. Another example, something very easy. We said x cubed was 1 to 1. So f of x equals x cubed has an inverse. Since it is 1 to 1. Okay, so we're going to let y be x cubed. Now we're going for the switch. We're going to get x is equal to y cubed. And I'm solving for y, so I'm going to raise this to the 1/3 power and take y cubed and raise it to the 1/3 power. And so now I get x cubed, x to the 1/3 power is equal to y. And so now I'm going to call y f inverse. So my f inverse of x now becomes x to the 1/3. So that is my inverse function.
Next to f of x has an inverse since it is, what's that? Is that a 1-1?
Yes, 1 to 1.
Okay.
Yeah, since it is 1 to 1. Okay, so let's see what the inverse looks like. So anytime you switch x for y, then you actually are flipping over and over the axis. Okay, so here's my function. Here's my curve. Okay. So f of x equal to x cubed looks like this. So what you do to find the inverse is you draw the line y equals x. And then you just flip the function over. So this red, the red is f of x is equal to x cubed. And then I'm going to flip this over. And the blue is f inverse of x is x to the 1/3. So graphically, in order to find your inverse function, you just want to flip it over the line y is equal to x, because that's what we did. We changed y and x. Okay, next one. So now we want to let f of x equal to x squared. But now we already know that f of x equal x squared as it is fails the horizontal line test. But if I restrict it between 0 and infinity, then I know it's going to pass the horizontal line test. So now I have y is equal to x squared. So switch them, do the switch.
Professor, are you writing something?
You guys can't see?
Well, it's frozen on my
It's,
end.
yeah, it's lagging.
It's lagging.
So it just came up. So did you stop writing at switch?
Yes, I did.
All right.
So now I get x is y squared, and now I need to solve for y. And then I'm just going to get x to the 1/2 is equal to y. And then now I need to rename y equal to f inverse of x. So I get f inverse of x is x to the 1/2, which is just the square root of x. So now I'm hoping you guys can see what I'm writing. And actually, I don't even need all that because we already said that we are only in 0 to infinity. So we already know that we're only going this far. So here is, whoops. This is f of x.
Professor.
Yes.
So for the solve for y you have x to the half equals y. Why wouldn't y be y to the half as well?
Okay. All right. So I skipped a step. All right. So the step I skipped is right here. I'm going to take x and raise it to the 1/2 power. And I'm going to take y squared and raise it to the 1/2 power. What do we do with the exponents? When you have an exponent to an
Multiply
exponent,
them.
you multiply. So I get 2 times 1/2, which is y to the first. So I have to take both pieces to the 1/2 power in order to eliminate the square. Okay. So here's my line, y is equal to x. So my inverse function looks like that. And this is f inverse of x equal to the square root of x. Okay. Any questions? All right, here's one more tough. This is a little bit tougher, not much, but just a little bit, just to keep us on our toes. We have f of x is equal to 2 times the square root of x minus 3. And the domain of this function, the set of all x, such that x is greater than or equal to 3. Whoops. So I'm on the interval 3, positive infinity. Okay. Now, if I were to graph this function, let's graph it for a moment. I would get something that looks like this. So this is f of x is 2 times the square root of x minus 3. Okay. All right, let's find the inverse. What's the first step to finding the inverse?
Switch.
Good. So I'm going to write y is equal to 2 times the square root of x minus 3. So let's switch x and y. So I get x is equal to 2 times the square root of y minus 3. All right. So I'm going to divide by 2. So I get x over 2 is the square root of y minus 3, and I'm going to square both sides. So now I'm going to get x squared over 4 is y minus 3, and that tells me that y is equal to x squared over 4 minus 3. Last step, rename. So I get f inverse of x is equal to x squared over 4.
Dr. Locke,
Yes.
I believe you may have forgotten to change the sign from negative to
That should
positive.
be, you're right. Thank you. I just looked at that and said, that's not right. Okay, thank you. That is plus 3. I knew that was wrong because my picture wouldn't be right. Okay, so here is my here, and then my function's going to start at 3 and go up like that. So f inverse of x is x squared over 4 plus 3. Okay, so that's how you do it in general. If I have something that looks like this, example,
Can you scoot the paper back up, please?
I can. That good enough?
Yes.
Okay. So if I have f of x is equal to x squared, let's make it x cubed. Okay, so this now we can let y x cubed minus 3x squared minus 4, and then we do the switch. So we get x is equal to y cubed minus 3y squared minus 4. And now solving for y is difficult. So some functions we may not be able to use this technique because it's rather difficult. Okay. All right. Let's look at our trig functions. Okay, so we have 6 major trig functions. We have the sine of x, cosine of x, the tangent of x, the cotangent of x, the secant of x, and the cosecant of x. And everybody should have a general working knowledge of what they look like. Okay, it's possible you may not. So let's start off with f of x equaling the sine of x. Okay, so the sine of x is an oscillating function, okay? And so I'm gonna mark off some places here just to help me out. Okay. Okay, so this is the sine of x. And so this function, as it is, fails, this fails the horizontal line test. So therefore, it does not have an inverse function. But if I restrict it, so right here, this is minus pi over 2. And this is pi over 2. And if I restrict it between those 2 points, and whoops, that doesn't look right. Because my function's a little crooked, but you know. Okay, so if I restrict it to only between here and here, notice that one little piece passes the horizontal line test. Okay, so we can define the function f of x to be the sine inverse of x, provided we're on the interval minus pi over 2 and pi over 2. So the sine inverse of x function works only in that interval. Okay. Suppose we have the cosine of x. Okay. Here's the cosine of x. I'm going to do the same thing. Okay, so this is the cosine of x. And notice that the cosine of x also fails the horizontal line test. But if I restrict it between here, what in the world? Okay, that's interesting. Why is it doing that? I have never seen it do this before. Okay, I have no idea what it's doing, but it's driving me nuts. Oh, whoa, whoa. What are you doing? Stop it, stop it. Okay. I have never seen it do that before. We're going to start all over again for a moment because I can't have it doing that. That is doing exactly what it wants to do. Not happening. Okay. So we're going to restrict the cosine between 0 and this is pi. Okay. All right, so now we want to define f of x equal to the cosine inverse of x. And it's on the interval 0 pi. Okay. Now, there are actually 4 other functions. Okay. So this is what we get. Okay. All righty. So number 1 is going to be the sine inverse of x. And its domain is minus pi over 2 less than or equal to x less than or equal to pi over 2. Number 2 is the cosine inverse of x. Its domain between 0 and pi. Number 3, tangent inverse of x, and its domain is minus pi over 2, which is not included in the interval, to pi over 2. So we do not include it. Okay. Cotangent of x. So we get the cotangent inverse of x. And its domain is 0 less than x less than pi, not included. We get the secant inverse of x. And that is 0 less than or equal to x less than or equal to pi. And then the cosecant inverse of x is minus pi over 2 less than or equal to x less than or equal to pi over 2. Okay, so you may have done this before, but it's not very difficult. So, for example, square root of 2 over 2 is equal to the sine. Oh, not what I want. I want y to be the sine inverse of the square root of 2 over 2. So what does that mean? If I take the sine of both sides, I get the sine of y is the sine of the sine inverse of the square root of 2 over 2. But remember, the function and its inverse just give you the function sine of its inverse. That just gives you the number. So that says the sine of y is equal to the square root of 2 over 2. So now I have to think, which angle am I going to get the square root of 2 over 2? But I have to be between minus pi over 2 and pi over 2. So that tells me that y is pi over 4. Okay. Y is equal to cosine inverse of the root of 3 over 2. So therefore, the cosine of y is the cosine of the cosine inverse of root of 3 over 2. So that says the cosine of y is the square root of 3 over 2. So now I have to think of what angle has the square root of 3 over 2 as its cosine. And that says then that y is pi over 6. Okay. All right, so those are those inverses. And here's one neat fact. That the domain of F inverse is equal to the range of F. And the range of F inverse is equal to the domain of F. Okay. So here's an example. Let's look at f of x. So here's the easy one. F of x is x cubed minus 2. So the domain of f is the whole real line. I can put everything in there. And the range of f is also R, the whole real line. Find f inverse, y is equal to x cubed minus 2. So y plus 2 is the, excuse me, switch them. X is equal to y cubed minus 2. So I get x plus 2 is equal to y cubed. So x plus 2 to the 1/3 power is equal to y. So f inverse of x is x plus 2 to the 1/3 power. All right. F of x is equal to x plus 2 divided by 2x minus 3. So what's the domain of f? It's a set of all x such that x what? What's the domain? What numbers cannot go into that function?
-2 and I believe also -1.5.
Okay, -2 can actually go into the function. That just will give me 0. I'm okay with that. But x cannot equal 3/2. You are correct on that. So that's the domain. Now the range is a hard one. The range you have to look at kind of in a sense, this is calc 2, right? So you have to look at the limit as to see what happens as x gets big. And as x gets big, this thing goes to 1/2. So the range is the set of all y such that y is not equal to 1/2. So watch this. Y is equal to x plus 2 divided by 2x minus 3. So switch them. X is equal to y plus 2 divided by 2y minus 3. So now I'm going to multiply, and I'm going to get x times 2y minus 3 is equal to y plus 2. So on the left-hand side, I'm going to have 2xy minus 3 is y plus 2. So now I'm going to get 2x y minus y this should be 3x. Okay. 2xy minus 2 what in the world did I do? Okay, y is equal to x plus 2 over 2x minus 3, switch them. X is equal to y plus 2 over 2y minus 3, multiply. X,
I have a
2y
question,
minus
Dr.
3.
Lott.
What's that?
I have a question. Were you trying to do the distributive property for x times 2y minus 3? Because you put
Yes.
minus 2 instead of 6, minus 6. What? Oh, wait, never mind. Should see.
I don't get a minus 6.
No, actually, I see it.
Okay. So I get 2x y minus 3x. Move the 2 to the left, move the 3x to the right.
Oh, you just jumped a couple of steps. Okay. Or maybe. Oh, I see it now. Okay, thank you.
Okay, so solve for y. So y, I get 2x, 2 times y. Why am I getting a 1? This is easy. Ah, that's what's matter. This should be a y. I'm writing the wrong thing. I subtracted y. That's better. I subtracted y from both sides, added 3x to both sides. Okay, I was writing the wrong thing. Okay, now I get y times 2x minus 1 is equal to 3x plus 2. So y is equal to 3x plus 2 divided by 2x minus 1. And now you can see that the domain of, oh, this is F inverse. So now I got to write F inverse. Equal to 3x plus 2 divided by 2x minus 1. And so now the domain of F inverse of x is the set of all x such that x is not equal to a half. And the range of F inverse is the set of all y such that y is not equal to 3 halves. Okay. All righty.